Hello everybody. In today's video, we'll be covering a mines chapter, and yes, that's all. So obviously, in the first paragraph itself, they've done a lot of information dumping. Like first thing is that adrenaline and epinephrine. Okay, that is wrong actually. Both contain secondary amino group and are used to increase blood pressure. Novocaine is used as anesthetic in dentistry. Benadryl is used as an antihistaminic drug, which also contains tertiary amino group. Quaternary amino groups are called surfactants. Are used as surfactants, and yes, this is the examples that they've given for amines. So they have given that because of lone pair repulsion, LPBP repulsion, okay, the bond angle of NR3, okay, NR3 is 108 degrees. This has been asked exact value in a PYQ, okay. So make sure to mark it up. NR3 bond angle is 108 degrees. Something that we always tend to miss is that simple amines are amines where all the aryl or alkyl groups attached to the N are the same, and mixed is when they are different. Obviously, I'll be skipping through the amines except the common names. Check this out: allylamine. It's named as alkylamine, like that. Okay, isopropylamine, ethyl methylamine, toluidine. Okay, toluidine, aniline, toluidine, bromoaniline, N comma N dimethyl aniline. This has been asked in a PYQ many times. Okay, here reduction of nitro compounds are very common. It's asked in PYQ. So they have said that we can use H2PD ethanol or SnHCl and FeHCl. Okay, this is very common reagents used for these kind of jobs. But this entire paragraph that I'm going to highlight is very important. Reduction with iron scrap and hydrochloric acid is preferred because FeCl2 formed gets hydrolyzed to release hydrochloric acid during the reaction. Okay, therefore, only small amount of hydrochloric acid is required to initiate the reaction. So that's why FeHCl is better than SnHCl. It's better than SnHCl. Now we have ammonolysis reaction, which is just regular SN2 type reaction, and this carried out in sealed tube. We all tend to miss that it's carried out in a sealed tube. Okay, and ammonolysis is the name of the reaction, and it forms a substituted ammonium salt as given. This reaction can keep on happening to form a quaternary ammonium salt, which is similar to Hoffman exhaustive methylation. When we take a large amount of ammonia, then primary amine is obtained because it is SN2 reagent, SN2. So primary reacts faster. And they have given a reagent called ethanolic NH3. Okay, so make sure ethanolic is used in majority of places. Ethanolic could be used, so don't get confused. So reduction of nitrile group. Okay, first you have H2Ni method, or we can use NaHgETOH, NaHgETOH, NaHg and ETOH. This can be also used to form, it's called ascent of amine series because you're adding another carbon. Okay, basically everybody knows LAH will just remove the C double bond O group and end up forming RCH2 and NH2 for acetamide. Okay, Gabriel synthesis used for preparation of primary amine phthalimide. Basically, this is phthalimide. Okay, mug up what is phthalimide. So phthalimide reaction with ethanolic potassium hydroxide will form negative charge over there, and then it'll do SN2 reaction. That's all. That's why it's only primary amine. For Hoffman bromamide degradation, we can use aqueous or ethanolic. It does not matter. Degradation, in the degradation reaction, basically what will happen is, it's the, you know, the mechanism right from the notes. So we have to mug up that 4 moles of OH is consumed and 2 moles of Br minus is formed. Make sure to mug this up fastly. In text questions are mid. Nothing is there new. Lower aliphatic amines are gases with fishy odor. Fishy odor. Three or more carbon atoms are liquid, and still higher ones are solid, basically. Number of, what do you say, carbon atoms. And yeah, this is very important. They've asked us in PYQ. Aniline. Okay, aniline and other aryl amines are usually colorless, but they get colored on storage due to atmospheric oxidation. And one thing you guys have to know is that Rishabh told in the group, if you provide NH2 aniline. Okay, for example, aniline you provide with Na2Cr2O7, K2Cr2O7, air, O2 in air, it forms benzoquinone. Okay, it forms benzoquinone, and that is partially why it is colored. So please make sure you mark that up. We all know that boiling point order is primary, secondary, tertiary, and primary amines are more in than secondary amines, and basic stuff. These all are. So I'm going to be skipping through this. They'll ask why is amines reactive? Difference in electronegativity between nitrogen and hydrogen makes the presence of unshared pairs of electrons over the nitrogen atoms make the amines reactive. Okay, it's a base. It can solve. It can create salts with HCl. It regenerates using a base like NaOH. It regenerates, guys. This is PYQ. It regenerates the parent amine after using base like NaOH. Basically, it's actually far stronger than Na2CO3 also. I mean NaHCO3. As a acid. This is a conjugate acid, right? It's actually stronger than NaHCO3 also. See, this is why they can ask steric effect in JEE mains, because they have given that steric hindrance, solvation effect, they all affect the Kb of amines, okay? Ka basicity. And they told us to ponder over it, but obviously we cannot because it's something that's not there in their book. So in gaseous phase, it is said that the order of basicity is normal for regular alkanamines. All right, but like they told in in aqueous solution, it is not. It is evident by the pKb values that it's not the same. See, they proposed one thing, all right. They proposed that in the aqueous phase, the substituted ammonium cations get stabilized by not only electron releasing effect of the alkyl group but also solvation with water molecules. The greater the size of the ion, lesser will be the solvation and lesser stabilized the ion is. Okay. So if solvation decreases, then stability will also decrease, but that can cause by increase of ion, size of ion. Now they're proposing that it should be primary, secondary, tertiary, which is opposite. Okay, primary greater than secondary greater than tertiary, which is only based upon the solvation enthalpy or solvation they have given. So they have yapped some bullshit which they can obviously ask in assertion reasoning. Secondly, when the alkyl group is small, like CH3 group, there is no steric hindrance to H bonding. In case the alkyl group is bigger than CH3 group, there will be steric hindrance to H bonding. Therefore, the change of nature from the alkyl group from CH3 to C2H5 change in results in change in order of basic strength. So they're just contradicting the fact that okay, this cannot be true because in 2 degree there'll be, I mean, in 3 degree there'll be, what do you say, no, I mean, in primary there'll be no steric hindrance, secondary there'll be a little bit, and tertiary there might not be. And they're talking about the change from CH3 to C2H5. All right, CH3 to C2H5, the order is different, and obviously the reason is kind of bullshit, but what to do. So for methyl, okay, it is 2 3 2 1 3, and for ethyl it is 2 3 1. They might ask stability. See, this is something that I also low-key forgot. Okay, there are five resonating structures available for aniline, but there's only two resonating structure for anilinium ion. So aniline is more stable. Okay, aniline is more stable than anilinium ion. So I don't know if you guys remember, but in esterification, we had one reaction of esterification with C double bond OCl R. And over there, we were doing esterification and the product was forming HCl. Now this HCl is removed by reagents like pyridine. Same thing can go by acylation for amines. Amines undergo acylation, final product is HCl, but HCl will again disrupt it, so that's why we use stuff like pyridine. Pyridine will absorb the H plus released because it's a weak base type. So an interesting common name is given here, acetanilide. Acet acetanilide basically. This is I'm assuming that this is acet, and one second, and this is anilide, aniline, acet, acetanilide. Methanamide, methanamine with benzoyl chloride forms N-methyl benzenamide, and this is common sense reaction. Everybody can do it, but it's called benzoylations. Then you have carbylamine reaction. Carbylamine reaction, you have to remember the stoichiometry, which is 3 KOH, 3 moles of OH are used. 3 OH minus are used. Remember that, please. Now, nitrous acid has come in a test recently, but basically, three classes can react differently. So, we have to prepare nitrous acid in situ, alright? So the reaction may be common sense, all right, diazonium salt and then formation of ROH, but quantitative evolution of nitrogen is used in estimation of amino acids and proteins. Again, let me repeat: quantitative evolution, which nitrogen is evolved, right? That is used in estimation of amino acids and proteins. Can be asked as a assertion. This is N nitro. So secondary amines form N nitrosamines. All right. So you guys know that Hinsberg reagent is nothing but benzene sulfonyl chloride, and yeah, it'll have a hydrogen, so it makes it acidic. I mean, if you react with 2-degree amine, it becomes insoluble in NH. Like it's not acidic and it's insoluble in alkali. Tertiary amines don't even react. This property of amines react with basically they're saying that you can only distinguish between like is used for distinction of primary, secondary, and tertiary amines and separation of a mixture of amines. Now, something that we always tend to miss is, however, these days, benzyl sulfonide chloride is being replaced by para-toluene sulfonyl chloride. If you guys want to know, here is the structure. Okay, so aniline reacts with bromine water at room temperature to give white precipitate, white precipitate, white precipitate of tribromo 4,6 tribromo aniline. So if you want controlled, then use acetylation. Acetylation reaction we have learned. We put this and pyridine, okay, pyridine, and you'll get Br2 and CH3 C double bond OH. And then yeah, you put the yeah, I told you know Br2 and ethanolic acid. Where have you seen this? Anisole wala reaction. You have seen this in hydrocarbons in CRT. Many times we have discussed it. So yes, this is the product. And again, they've used the word acetanilide that I've told you 60 times about what is acetanilide, and they're just showing how resonance works. Basically, they're saying it the reason it's less available lone pair, so that's why the activating is less than a minor group. Now, biggest question is why is meta product formed? Because see, nitric acid in a strongly acidic medium like H2SO4, it'll form NH3 plus, right? Now this NH3 plus is meta directing, so that's why meta is 47%. Para is still major, which is 51%, and this is 2%. Then we have protection of NH2 group by acetylation reaction. Acetylation reaction, this is easy, this is easy. And then HNO3, HNO2, yeah, it's everything is the same. You protect the aniline group. So sulfonation may we have first formation of anilinium hydrogen sulfate. Anilinium hydrogen sulfate. Then after that, when you pass heat, okay, or steam distillation type, when you pass heat, all right, onto anilinium hydrogen sulfate, it in presence of sulfuric acid. Make sure it's in presence of sulfuric acid. Then you'll get sulfonyllic acid, and it is also Zwitter ion. They have asked it in mains this specific question. It's a Zwitter ion, all right. When we've learned about Zwitter ions before. So Friedel-Crafts reaction aniline does not undergo because of salt formation with ammonium chloride, which is a Lewis acid used as a catalyst. Due to this, nitrogen of aniline acquires positive charge and hence has a strong deactivating group. Bro, they will twist shit up. They'll write meta directing over here. Everything else will be correct. So then you have to mark reason is false. That's how it works, bro. Make sure you read every single line carefully. So aniline with benzoyl chloride gives you benzanilide. See, acetanilide I had explained, which was this one, right? CH2C, and then N, and then you have aniline, which is C6H5. but now it's called benzanalide. Diazonium salts have general formula RN2X, where Rx can also be BF4 minus and HSO4 minus. Please make sure you mark it up. And they gave common names: benzene diazonium hydrogen sulfate, benzene diazonium hydrogen sulfate, benzene diazonium hydrogen sulfate. That is a common. Remember that um aromatic amines, primary aromatic amines, uh whatever diazonium salts they form, they're stable for a short time in low temperatures. And they've given the diazotization reaction, which is in situ preparation of HNO2 in 273 or 278 Kelvin, and formation of the diazonium salt. Now, physical properties is something that's crazy. Okay, benzene diazonium chloride is a colorless crystalline solid, crystalline solid, readily soluble in water and stable in cold water, but reacts when water is warmed. It decomposes easily in the dry state. Benzene diazonium fluoroborate is water insoluble and stable at room temperature. I bet 99% of the aspirants don't know this. Now, Sandmeyer reaction. Okay, Sandmeyer reaction is CuCl2, Cu2Br2, and CuCN. And yes, and Gatterman reaction. Gatterman reaction is when we use copper powder. Okay, halogen acid in the copper powder. Gatterman reaction is CuHCl. Sandmeyer is Cu2Cl2. Now, one thing that we always tend to miss is that the yield in the Sandmeyer reaction is found to be better than the Gatterman reaction. Yield in the Sandmeyer reaction is found to be better than Gatterman reaction. Iodine is not introduced into the benzene ring directly, but when diazonium salt is treated with potassium iodide, iodobenzene is formed instantly. Now, replacement by fluoride ion, fluoroboric acid. Arene diazonium chloride is treated with fluoroboric acid. Arene diazonium fluoroborate is precipitate, okay, is precipitated. Basically, it forms arene diazonium fluoroborate, which is stable, okay, basically is stable at room temperature and water insoluble and stable at room temperature. And if you heat it, then only it gives ARF. Remember hypophosphorus acid, which is also called phosphinic acid, and ethanol reduce diazonium salts to arenes, and they themselves get oxidized to phosphorus acids and ethanol to ethanol, and hypophosphorus to phosphorus. Very simple mechanisms. So for some reason, in replacement of NO2 group, we use diazonium fluoroborate is heated with aqueous sodium nitrite solution to give NO2. Right? Basically, first it forms fluoroboric acid. It forms diazonium fluoroborate. Then fluoroborate is heated with NaNO2Cu, and then it replaces the entire diazonium. We cannot. Why can't we directly use it? I don't know. But you use the diazonium salt to form fluoroborate, then you create the NO2, and NaBF4 is released. Dye formation, guys, dye formation. See, yellow color is with N. I told you, right, in the previous chapter in coordination compounds, when it's linked with N. Okay, NO2, when it's linked with N in that specific compound in linkage isomerism, it shows you what? Yellow color, right? So same way you can remember like this. In diazo coupling in OH will give you, what do you say, orange color dye, but in NH2 it will give you yellow dye. I thought this paragraph will be useful, but it's absolutely useless. So the only useful thing that I did not know, bro, was this HbF4 formation. HbF4 forming a diazonium fluoroborate, and then it forms your NO2. So that is a very important reaction. It has not been asked in JEE mains. So thank you guys. Here directly they have given this reaction. Here directly they have given this reaction. We'll just write the product, bro. I'm telling you, it's gonna come in JEE mains 2026. N2BFO minus, and then after that it forms your NO2. All right. So please make sure to stay in touch with all these topics, especially the NaHG that we also went through, right? The NaHG, All those small things, they can be asked, they can be questioned to you, they can be questioned to you, bro. It's like crazy actually. Where the hell did it go, bro? Wait, 1 second. Wasn't it up? Oh no, it was down only. Sorry. I'll find it, I'll show it, and then I'm gonna cut. I don't give a shit. Fuck man, where is it? Stupid ass. Bro, you know it though. Like, I'm pretty sure it's covered somewhere in this video. Please, just please go through it. Thank you so much.